Class, we're about to start section 2.7, and as we see here in our syllabus, 2.7 only covers page 192, problems 1 through 7. Okay, but we're going to turn first to page 191 and pull that up real quick. And we have our learning objectives. Says to decide on an appropriate type of model for a given data test, model data with a linear or exponential equation, research current data to compare it to values predicted by a model. Now, we'll look down here at the bottom. Says if you're like many students, you're concerned with the cost of attending college. It's certainly not a secret that college tuition has been rising rapidly over the last 20 to 30 years. But what are the facts? For that, we need some data. The table below lists the average tuition costs for all public American colleges and universities for a variety of school years starting in 1981. Now we have our tables here, as shown here, and as we see, the cost for tuition has gradually and steadily went up. Okay, now, on page 192, to analyze the data and look for patterns, we've seen that scatter plots can be a useful tool. We've also seen that when modeling data based on time, it's a good idea to choose input values based on time passed since the first data value we have. In this case, we should use inputs that correspond to the number of years since 1981. Fill in the table of values using the information in the last table. Your X value should be years since 1981, and your Y value should be the average tuition cost for that year. Now, on the back here, if you notice, we have our years since 1981. And what I'm going to do here is this. What you're going to need to do is maybe flip over to page 192 and then fill in the blanks. Because 1981, just to show you, since years since 1981, this would be 0, this would be 10, 20, 21, 22, 23, 24, and then this would be 25, 26, 27, 28, 29, and 30. And then the cost would be the cost that you see. So I'm going to fill this in over here. Say 0, 10, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. And fill in all of these numerical values for the tuition. Let's see, 92.47, 98.64, 10,454, 11,049, 11,573. Okay, now we have all of these values filled in the chart. It says draw a scatter plot of the data in your table. Make sure you choose an appropriate scale for each axis and clearly mark that scale on your graph. Okay, now the thing about it is, remember, we switched everything for years since 1981. So if you notice, we go from 0 to 30. Now looking at these tick marks here, we have about 34, 35 tick marks for the year since 1981. So we would start here at 0. And then we would go 5, 10, 15, 20, 25, 30. And then we know it would go so on. Now, the next thing we would do is plot these points. We would have 0. Well, first of all, we have to do the average tuition cost. Now, this also would be 0. But if we notice, the tuition goes from a little over almost well, a little over 2,600, well, more than halfway between 26 and 2,700, all the way up to a little over $14,000. So if we look here at these tick marks, we could do everything, let's say, by 1,000. So this would be, let's just go by, let's go every second one. So this would be 2,000. This would be 4,000, 6,000, 8,000, 10,000, 12,000, 14,000, 16,000, and we don't even need to go any further. Okay, so now that we have this set up, now we can mark our values. So we are going to have to do a few approximations. Now for our 0 year, this is 2,000 and we're going every 1,000, so it's going to be a little bit above the halfway mark. Then our 10th year, we have a little bit over 5,000, to be about here. Okay, next we jump from our 10th year to our 20th year, and this is where a lot of the data is going to be pushed together. Okay, so we have our 20th year, and it's just slightly over 8,000, a little bit. 21st year, we have 8502, which is slightly over half. Then our 22nd year, we will have a little bit over 9,000. Then our 23rd year, oh, you know what, I marked this in the wrong spot. Okay, so this is our 22nd year. Then our 23rd year would be almost 10,000. So I have to X that out. Our 24th year would be a little over 10,000. Almost 10,000, almost at the middle of between 10 and 11,000. And then we will go, our 25th year will be a little over 11,000. Our 26th year would be a little bit over the halfway point between 11 and 12,000. Our 27th year, we will have a little over 12,000. Our 28th year, it'll be almost 13,000. Our 29th year, we will have 13,000, a little over the halfway mark between 13 and 14,000. And then finally, our 30th year will be a little under half, between 14 and 15,000. Okay, this is our scatter plot. Now, we move on to the next page. Now, problem number 3. It says, based on your scatter plot, which type of equation do you think will most appropriately model the tuition data, linear or exponential? Now, we're not saying that it has to be perfect, but what we see here is this almost is a straight line. It's very close to being a straight line, so it'll be linear. Because the points seem to line up very nicely. So a linear equation seems to be the best fit. Okay, number 4. Using a graphing calculator or a spreadsheet, find the linear equation of best fit for your data. Round all coefficients so that they have 5 digits total. Now let's go back over linear regression. Okay, so with linear regression, let me pull up my calculator here. Okay, now with linear regression, the first thing we have to do is press stat. And we'll go to edit and press enter. Now if we have anything in L1 and L2, we'll press the up arrow, press clear, go down, and then go over to L1, press clear, and go down. Okay, now what we have to do next, we have to type in all of the values from the previous chart. So we will bring that chart back and we will type in all of those values. So L1 is our X value, so we'll press 0, enter, 10, enter, 20, enter, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Then we'll go to the right to L2, 2663, 5138, 8022, 8502, 9247, 9864, 10,454, 11,049, 11,573, 12,256, 12,804, 13,564, and 14,292. Now we have all the values in. Now once we get all the values in, we press stat again, hit the right arrow to calculate, and we go down to linear regression and press enter, and then we would press enter until it tells us to calculate. Now we have our values, so we go back to page 193 and they tell us, let me see, they want us to round all coefficients so that they have 5 digits total. Okay, so that means basically for our A value, y equals, because in the calculator instead of putting the M they put A, but it's still the slope. So it'll be 385 point. Since this is 3 digits, we only need 2 digits behind the decimal. It'll be 0.66, and we'll put X. Our B is positive, which is our y-intercept, and we have 1,501 point. And since we have 4 digits already, we only need 1 digit behind the decimal. And that is our final answer for number 4. Okay, now it says graph the line of best fit and your scatter plot on screen. Based on the graph, how well do you think your model fits the data? Okay, so now what we will have to do next, we will have to go to y equals, clear out anything we have in y equals, and type in the equation we have. We already have the y, so we'll do 385.66 and hit the X key, plus 1,501.2. And if you missed that, the X key is right next to the lime green alpha key. Now, before we graph, let's just make sure that our plots are on. So we'll press second and y equal. And then here, if your number 1, if your plot 1 is not on, all you have to do is just press enter twice. Again, if your plot is not on, just press enter twice. Now, our next step, we will press zoom, and we will go down until we get to zoom stat, and then press enter. Now, if you look at this graph here, now it looks okay, but it is not as good as we thought, because the earlier points cause the line to tilt. So basically, if we didn't have those earlier points in the graph would look a lot better than what it does. Okay, now it says, what is the correlation coefficient for your equation of best fit? Does this change your perspective on how accurately the model fits the data? Okay, now, we got a couple things going here. First of all, let's go back to our linear regression. We already put in our x's and everything like that. So now we go back to our linear regression. What we're trying to do is find what R is equal to. Now R is equal to 0.97. So we will put down that no, this confirms that it is good, that it is a good correlation, but not perfect, because we know R equals 1 would be perfect. Okay, now, some of you may be asking, how come I don't have R showing up on my calculator? If you do not have R showing up on your calculator, this is what you need to do. You will need to press second and 0. It'll take you to your catalog. Now, after you get to your catalog, the next thing you would do is you will press, if you see here, you go to second and you'll go down 1, 2, 3. You'll go down to this key here, this x to the negative 1 key. You will hit that key. And if you notice, the D's come up. You have to go down until you get the diagnostic on, not diagnostic off. And then press enter twice. And now it's done. Now you press stat, go back to calculate, and then linear regression. And now your answer should have the R. Okay, now we go to our last problem for this section. It says, write a description of what the slope of your linear model tells us about the growth of tuition since 1981. Be very specific. First of all, our equation was y is equal to 385.66x plus 1,501.2. Our slope is always the number. Our slope is always the number connected to x. So this equation estimates that on average tuition increased by $385.66 per year. So our slope is 385.66. So it tells us that our tuition increased by $385.66 per year. And we are done.